Do you know how much money India spends every year just to maintain and monitor our railway tracks? The number goes into thousands of crores. And yet, most of the technology we use is imported, making it expensive, hard to maintain, and not always suited for Indian conditions. Now, think about this: India has the fourth largest railway network in the world. But with these limited systems, it is impossible to monitor every stretch of track in real time. The result? Delays, unnecessary speed restrictions, and sometimes even accidents. That is exactly why we developed TrackWatch, a smarter, more affordable, and fully indigenous solution for railway track monitoring. We are Team 404 found, and our problem statement is development of indigenous contactless integrated track monitoring systems for track recording in Indian Railways. TrackWatch aims to reduce costs, improve safety, and make real time track monitoring possible, designed entirely for Indian conditions.
Our solution is TrackWatch. TrackWatch will reimagine how train monitoring system works in India. So we are going to build an e-portal plus onboard system that makes the track inspection simple, fast and local. The railway inspectors who are sitting at the back end will use the portal, get the reports by the sensors and detect if there is any fault or not. All of these data is going to be selected by the TRC while it is running real time, and the data is being processed by the in the portal by simple ML models, and then it is being represented in plain English language that the people at the back end can understand very easily and see the next recommended steps. All of this being processed at the back end itself. So how are we different? So we are going to have chainage map reports as decided by the normal standards every 0.25 meter, and then we are going to have real-time data analysis by our sensors. Our data is going to be small modular units, and it is going to be replaceable anytime without affecting the whole of the prototype, and the website is going to be secure, and it will be able to store the data at various formats that we need at handy, and it will help in predictive maintenance at its own. Thank you.
I'll be talking about the technical approach to our project. The first step is sensing and measurement. We make use of various sensors and cameras in order to measure the relevant parameters. The second step is data acquisition and process. Using an onboard computer to process the data measured, we analyze the track condition as well as the defects in the train and the train tracks. The third step is output and visualization. We make use of display screens and communication modules which show the output. This output will be read by the technicians as well as experienced engineers who will identify the defects and fix them as soon as possible. And the last step is in order to implement support systems. These support systems include power supply and uninterrupted power supply in case there's a power shortage, as well as backup storage devices in case the data on the cloud servers gets deleted. So we have the onboard data in the storage devices. I'll now be talking about the sensors which are being used in this project to measure the relevant parameters, as well as the software and the AI which is being used behind it. The first type of parameter is track geometry measurement, and the sensor being used is laser displacement sensor. It measures the vertical and lateral displacement of each rail for the gauge, alignment, and cross level. We will be making use of a machine learning, that is convolution neural network CNN. Its use is for image and video analysis, and it detects cracks, missing fasteners, sleeper damage, and so on. The second type of sensor being used is the 2D laser line profiler, which is used to measure the track profile and rail wear. It captures the rail head shape, that is the cross section of the tracks, and detects wear and tear. Here we make use of a recurrent neural network, which is used for time series vibration geometry data collection, and it is used to analyze sequential IMUs and encoder signals as well. It detects patterns of track irregularity over distances and predicts future degradation. The third type of sensor being used is the inertial measurement unit, which measures the acceleration and vibration. It measures vertical, lateral, as well as the vehicle dynamics. Here, we can make use of the random forest machine learning module, and it is used to classify track conditions, whether the track condition is good or bad. and predict maintenance behavior, which is based on the sensor data collected in previous rounds. The fourth parameter being measured is chain mapping, which makes use of a rotary or axle encoder, and it calculates distance traveled and the track chainage. The fifth parameter being measured is position reference, which is the sensor being used is GNSS, that is GPS module, and it maps track coordinates, adds GPS tagging to the data. And here we make use of a clustering model. It helps group track sections by conditions or type, and it is used to identify sections which have a similar defect pattern, as well as it measures the environment of the segment track. The sixth component being used is track component condition monitoring, which is making use of an industrial camera. It detects the broken fasteners, missing clips, sleeper cracks. The seventh parameter being measured is the rear view, which is making use of an HD camera. It is so that we can record synchronized rear footage for the validation with the track component condition monitoring. The eighth sensor being used is a LiDAR sensor, which is to check for clearance and structure infringement. It scans nearby objects and structures for MMD and SOD infringements. There are further auxiliary sensors which include a temperature environment monitoring as well as power health monitoring, which is used to measure temperature, humidity, and voltage current sensors respectively.
So this is a 3D prototype which we have created using a software known as Autodesk. In this we have showcased the placement of the sensors that we are going to use in our model. So this is made using a material known as mild steel, which meets our criteria for the final prototype. So the sensors that we used are, here's an encoder, this is a rear camera, here's a temperature and humidity sensor, here is a GPS module, below this is an IMU and a power motor. Here we have uses 3 laser sensors, which is first here, second here, and third one is below the LiDAR sensors. The last 2 sensors are front camera, which is here, and finally the LiDAR sensors. All these sensors are interconnected through the IMU, which showcases our parameter in the final website.
This is the login page for our integrated track monitoring system, and we have created the custom username and password. So I will be entering it. So after logging in, we have here the ITMS dashboard. We have 2-3 table crack monitor, detection status and track parameter status, and we also have the track geometry. So here we have graph something, and we have track parameters, which is standard from the Indian Railways. And in the crack detection status, we have 3 columns: monitoring, resolved, and unresolved. So between Delhi Ghaziabad, we will be having the monitoring is going on, and we can have the location of that Google Maps. So here we have the cracks. So here it is a location. So like this we have same for resolved and unresolved. You can see here on Google Maps, and this. We also have the track parameter status, in which we have different parameter on which we decide if there is a crack or not. For example, if we talk about gauge, so here it is exit by 0.2%, and we have the GPS location coordinates. And if we talk about here, we have also have the location of this, and here the sensor type and measuring principle and detection time, also the issue description. So it is same for this all. You can see here we have Google Maps and issue description. So we also have live monitoring, so we can have the live reports, and we also have the report tabs. After the monitoring is done, we have the everything about cracks. So we also have classified here track geometry, crack detection, components. So by specification, by filtering out, we also can download here like this, and we can also have the CSV, XML, and PDF format, and we can also, and this is our ITMS dashboard. So thank you. So as you guys have seen all of our presentation, so here I am to walk you through our drive. In our drive, we have submitted a PDF of the template explaining our idea, and then here we have our budget report as prescribed by the Railway of India, the budget report. and we also have submitted a 3D model. Soon we will be also submitting the link to our website so that it can be directly accessed from our web, so that you guys can directly access our website. So yeah, this is TrackWatch, and we hope you liked it. Thank you.